Hello, can we start?
Okay, you can start.
Ah, thank you. Hello, good evening, everyone.
Sorry, can you turn on your camera, please?
Yeah.
Okay, thank you so much.
Uh, Good evening, everyone. This is Mohammed Saklan. Today we will continue our lab group presentations. So, so the topic of today's presentation is decision making using fuzzy hypersoft with machine learning. Under the supervision of Professor Dr. Kuntla. So some outlines of my presentations are the process of decision making. What is decision making, and what are its the stages, and then we will consider a case study or a problem. Then after that, we convert it into the mathematical modeling, and finally, with the help of fuzzy hypersoft we will solve this problem. And the most important thing is we will see the demonstration using Python language, and then we will conclude this presentation. So, what is a decision making? Decision making is a process of making choices by assessing some information and by weighing some pros and cons of uh, the products or something and considering the consequences. The most common example is when we have to buy a cell phone or a laptop. So what we do, first of all, we collect some information that what brand we are going to purchase, what are its specifications, what are our requirements. We discuss with our colleagues, we discuss with our seniors, we discuss with friends, and the most important thing is the price or the budget. So all the things we do, and then finally we go for the purchasing. So this process is said to be a decision making. So the decision making process has some steps. The most important, first of all, we have to consider a problem, a case study, and then after that we will consider some collect some information about that case study. We will identify the alternatives and the criteria of that problem, okay, and we calculate the probabilities, and finally we calculate uncertainty by applying the MCDM techniques. So first of all, a problem. So this is a small. Jenny is a small farmer in a rural region, and she has a very tiny family, labor force, a limited amount to invest, and the most important is the farming tools. So she previously grown a variety of crops such as maize, soybean, and vegetables, but due to some economic variables, the shifting market price and the climate circumstances, it is very important to see, select a crop which can optimize her production. So she wanted to increase its crop production and the profitability using its resources. So this is a basic problem, and now we will apply our decision making on it with the help of the Microsoft. So first of all, we have to gather some information about this problem. We have to uh, select alternatives and criteria which she consider important in this problem. So the graphical abstract can be presented in this form. So information gathering, how she will gather some information? She will investigate the market price, market trends. She will discuss with the nearby customers and consulting with the agriculture authorities. And the most important is she researches agriculture price estimates, historical productions, statistics, and weather prediction. So these are all are the requirements or the necessary information which she will get. So after information gathering, she will identify the alternatives. So Jenny selected 8 possible crops. from A1 to A8. A1 is the rice. So these are her alternatives which can she can uh, select in for her form for the production purpose. So after these alternatives, the most important is the selection of the criteria that rewards. So C1, the criteria is the demand. So whatever she is going to select for his form, so that must have some demand in the market. So we have further subdivisions, medium, low, and high. Likewise, the sale price, what is are her expectations. So at finally, when she harvests, so what will be the sale price at that moment? That will be the expected price, obviously. The next is the weather condition, maybe a flood, a high temperature, or so we will further subdivide it into favorable, moderate, and unfavorable conditions. Likewise, the fourth criteria is the harvesting cost. Is she going to harvest the crop? She must have some cost, so maybe medium, low, or high. Likewise, what is the soil fertility of soil? So the, maybe a fertile, moderate fertile. The sixth criteria is the cost, seed cost. So that again can be a low, medium, and high. And the last one is the irrigation facility. So she has, according to the Jania farmer, she considered these seven criterias can impact his productions, can optimize her production. So calculating the probabilities. Now, as we have discussed earlier, she will collect some statistical data from the past. So she collects some historical data, uh, the informations, and she makes some professional judgments and of the possibilities of the selections of our crop. So now the next is examining the risk tolerance or the uncertainty which she can consider. So due to her limited financial means, she can take a limited risk also. She can take more some crops that maybe can optimize the productions, but maybe there are a high uh, chances of you can say there is. So it is very important that how much she can take the risk depending upon her resources. So now the most important thing is the uncertainty. So in this case study, she may face the four uncertainties: the market pricing, due to the shifting market price. This is a very serious problem worldwide now. So the uncertainty number one. The second is the weather condition. This is once again a universal problem in the world that every country is facing due to some climate changes. So weather conditions, what will be the weather condition during the crop production stages? The next is the production cost. Uh, how much she can afford. That is also an uncertainty. And the most important is market demand. So what is the demand of the market? So these are the four uncertainties, and if she can tackle with them, she can optimize her production. So how these uncertainties can be calculated or can be solved? So there are some common methods. The most important is multi-criteria decision-making methods. The techniques, which includes the Topsis method, Y4 method, multimodal electric rule. Secondly, statistical techniques can also be applied. For example, the logistic regression, time series, clustering problems, and decision trees. And nowadays, the big data calculation methods, the machine learning or the deep learning techniques can also be applied. So the machine learning tools normally includes the linear regression, decision trees, random forest models, and many more. So with the help of these techniques, uncertainty can be calculated some other approaches are MCDM approaches are the aggregate operators, the matrix simplification methods, the similarity measures, correlation coefficients, algorithms like as we have discussed earlier, and the machine learning. So these are methods depend upon the case study, whether we can apply which one is the most favorable in that case study. So the selection of approach is very important. Similarly, the machine learning approaches includes the supervised learning methods, which includes the linear regression method, the logistic regression method, decision trees, random forest, vector swap methods, and many others. Unsupervised learnings also includes the clustering algorithms like k-means and hierarchical clusterings, etc. Deep learning includes the image recognitions, natural language processing, and speech recognition. Assembling methods and neural networks are also the machine learning approaches that can be applied in the decision-making methods. So now the step two. After the decision-making stages, the second next is the modeling of the problem. This modeling includes the construction of Hypersoft set because I'm going to solve this problem with the help of Hypersoft set. So uh, first step will be the construction of Hypersoft set. Secondly, we will assign values in the form of fuzzy, and then the selection of the MCDM technique, which one is the appropriate one, and we will calculate the problem with the help of that method, and then we will calculate the results. So the Hypersoft set. The Hypersoft set is basically a mapping which is from the product of the sets. So product of sets to the power set of alternatives. And these sets A1 to AN are the attributes, which are the sets. Means that these sets have some further values. So if we define a mapping from the product of these sets to the power set of alternatives, then the outcomes, whichever the possibilities we consider, is set to be the Hypersoft. So now the modeling of our problem. So we have 7 attributes, C1 to C7. If we consider the product of these 7 sets, and as we have seen earlier, C1 to C7, every criteria has further subdivisions. The values may vary. So the product from these sets to the power set of alternatives will be the Hypersoft set. And Jenny, a farmer, which is now a decision maker actually, and she intended to select the most suitable crop for her farm based on the decision facilities from of attributes. So these are the attributes as we have discussed. So every C1 to C7 has further subdivisions. Before Hypersoft set, these subdivisions cannot be considered, but with the construction of Hypersoft set, now these subdivisions help us to get our results more accurate and more clear. So the construction of Hypersoft set now, the Jenny farmer will assign values to each alternative. So A1, the criteria 1, she will assign a value in the form of fuzzy, likewise C2, criteria number 2, and up to C7. And in this way, she will assign values to all the 8 alternatives for each single criteria. So now we have a fuzzy Hypersoft set. So as this problem simplification includes the construction of fuzzy Hypersoft sets, and the next is the selection of MCDM approach. So the selection of MCDM technique, we have selected Multimura method. This was initially introduced by uh, Juras in 2010 and 2009 and 2010. With the help of this method, uh, basically it has 3 stages. The stage number 1 is The ratio system approach, we calculate the ranking of the alternative in the form of ratio system approach. Secondly, the reference point approach, and finally the full multiplicative form. So we calculate this with the help of multimodal. We calculate these three with the help of these three stages, the rank of the alternatives, and finally, with the help of dominance theory, the rank number one alternative and each approach will be considered as the optimal choice. So the MCTM multimodal algorithm has 5 stages. First, construction of decision matrix we have already did. The ratio system approach we have to calculate. The reference point approach we have to calculate the multiplicative form, and finally the best estimate. The most important point here is the weight to each criteria. So weight means we have 7 criteria. So what is the importance of each criteria in the optimization process? What we think, irrigation is important, soil fertility is important, the demand in the market is important. So we cannot decide, we cannot select from our mind that this one is the highest with the highest importance, or this one is with the least. So the calculation of the importance of these criteria is important, and that has been done with the help of entropy method. And we have calculated the weight for each 7 criteria. And the most important point here is the sum of these criteria also should be equal to 1. So with the help of entropy method, we have calculated the weights, and now we will apply the ratio system approach, the reference point approach, and the full multiplicative form approach. So the RSA approach has the following mathematical steps: the consideration of the alternatives, then the calculation of their least important and most important, and then with the help of weight multiplication, we will calculate the decision matrix. Similarly, the RP approach has some mathematical stages, which includes the relative extreme distance of the alternatives with the ideal one. So in this way, we will calculate by applying this RP approach. Similarly, FMF approach has some mathematical stages, which has the ratio, total efficiency of the alternatives could be obtained by applying this ratio, UI, calculating the UI, which is the ratio of AI to BI. And what is AI? Alternative AIs are the products of weights to ideal solutions, and similarly the BIs. So if we calculate these three approaches, then we can say that which one is the optimal uh, alternative. So I have calculated, and with the help of RSA, RPA, and FMF, we have a result, scores of the alternative, and we can see that Y7, the seventh alternative, is the best one, and the second rank alternative is the A8 alternative, and third one is A1. So now with the multimura approach suggests that the top ranked in each approach will be the most favorable alternative. And we can here see that it is A7, alternative number 7 is the most favorable alternative. So A7 is the maize in our selection table, and A8, which is the second one, that is the tomatoes, and A1 is the rice. So maize, tomatoes, and rice she can select for a form to optimize this. So with the help of multimura method and the construction of hypersoft, she able to make more sound and educated decisions by using this advanced strategy to account for the uncertainty brought by few facilities and resources. Now the machine learning. So this study has been strengthened not only with the mathematical approach, but also we have applied a random forest model, the machine learning approach. This model suggests that each alternative must have some deviance, and in our criteria, we can see that each criteria is further subdivided. So, but we don't know the importance of these criteria, the relation between these criteria, whether they are dependent, whether they are independent or interdependent. So this was unknown in the mathematical approach, but with the help of this RF model, we can calculate uh, their correlations, how they are linked with each other. So by applying the machine learning approach, we have calculated their correlation features, uh, which can be shown here. And finally, the rankings has been calculated. So once again, we can see that these feature rankings shows that A7 is the top ranked alternative, A8 is the second one, and A1 is the third one. So machine learning, random forest model, and the mathematical approach that we have applied, Multimura, both have the same results. So which strengthen our study, validates the structure and the problem that we have solved in this way. So we can also demonstrate this with the help of Python. I prefer to solve my problems with the help of Google Colab Library. No need to install Python in our systems. So I have some coding for this problem, and after doing, we have to import our data, the alternatives that was from A1 to A8 and with fuzzy values. So by calculating and the correlation features, I have calculated the rank, and which can be seen here, A1 to A7. The here important thing is that if we train this model, we can train this model like I have trained to estimate to 50 times. It can be increased up to 100, up to thousands, millions. This may take some processing time, but the thing was that the results were a very slight difference. So uh, this can be increased in the future. The accuracy can be increased, can be optimized by considering more criteria and further deviance of each criteria. So this was using the Python language. And now once again, so the results that we have obtained using the Multimura approach and the random forest model, both are approximately the same. So now Farmer Jenny can further optimize the decision-making process, increase farm outputs, and she can support the sustainable agriculture practices. She invests the future and cooperating. In future, more real-life applications can be solved with the decision-making approaches like Echo, Topsys, Electric, by employing the set structures like intuitionistic set structure, hypersoft set, the neurosophic hypersoft set, and Curon hypersoft set. And the problems that real life problem that can be solved, some of them are listed here. That includes the public policies, automation control, the fuzzy logic controllers, the shortest path selections, air quality index control calculations, and energy production site selections, the industrial optimization control. So there are some references that have been used in this research, in this presentation. The publications that have been made in the last few days or months. The second one is the linguistic hypersoft set with application to multi-criteria decision making from enhanced rural health services. Is the most important because this paper suggests the rules how linguistic values can be assigned, uh, how fuzzy values can be assigned to the linguistic values. And this has been accepted in the Statistical Group journal with impact factor 6. And uh, the linguistic fuzzy valued hypersoft set that we have presented here in this lab presentation, uh, its extension has been accepted in the 7th European Conference on Electrical Engineering and Computer Science in Switzerland. Some important results that I have used in this research is the hypersoft set articles which suggest the fuzzification and the defuzzification methods, that how we assign the linguistic values, fuzzy values to the linguistic, the low, medium, high can be traced from these articles. The entropy method, how we have calculated the entropy of these criterias, and the random forest model machine learning. Thank you for your attention, for listening. The questions and
Any
suggestions
question?
are welcome from
Okay.
our.
So sorry, I have some. I'm interested that the work. Can you show me for some formulate the problem of your work?
Yeah, sure. This one.
So for the formulate your problem, that when you setting variable parameters and
This one.
yeah. Okay. What is if this the flexibility set, right?
Yeah, it's a mapping test. Yes, possibilities.
Okay. This you apply for the machine learning, right? Of the
Sorry,
work.
can you repeat your question?
What your application again, please?
The application was the same. The application was the same. I have selected the same this decision matrix
Mm-hmm.
in the machine learning. Yeah. But
Your formula, your problem is
the problem was the selection of optimal crop for farmer. This one was a problem. I have solved this problem with the help of mathematical decision-making approach, multimodal, with the help of hypersoft set, fuzzy hypersoft set. And the same problem has been solved with the help of machine learning, random forest model. Both the results, both the rankings are the same.
Okay, but and I'll see for your formulate the algorithm. Your algorithm is, but and I'll see in your slide. So I argue later. Okay. Any question?
Okay, sure.
Okay. Thank you. Thank you so much. Okay.
Anyone more?
Hello.
Okay, Asoka.
Alright.
Okay. Uh-huh.
Yeah, please, can you go to that hyper subset? The clean, okay.
Okay.
Yeah, okay. This A. What is this A? I think how did you define this A?
A
The
are the
poset of
sets,
A.
the
A is what?
criteria.
The what?
Criteria that we have
Criteria.
considered. Yeah, in next slide, I have modeled where this problem.
In the next slide.
This
Okay,
one,
let's
yeah. So you can see C1 to C7 are criteria, which are the sets basically. which has some further values. So this this C1 is a set which has some further values, high, medium, and low. So
I
if
don't understand
we
this one.
yes, if we define mapping, so another way you can say a power set from C1 to C7. You take the product, all the possible, whatever the possibilities in this case study. So if we define such a mapping, so we call it the hypersoft set.
Okay, thank you.
Mr. Clear?
Yeah.
Yeah, sorry, please go back to your formulation. That is F a map F1. Yeah.
Yes, yes.
Yeah. What is this F? Sorry to
This
take.
is this F means just a mapping, the output from A1 to A7, which we have these
Yeah.
7 criterias, which has some further divisions like medium, low, high, something like. If we take a product, the power set of all the alternatives that we have here, so or you can say the relations, all the possible relations that can be defined from these 7.
Yes,
So that can be represented
I
with that.
understand all this. My concern is just
Yes,
I'm
sir.
just looking at this formulation of this particular F. I'm
Okay.
trying to look at the possibility of relating this to my work so that I
Okay,
have maybe a possible application in
So,
this direction.
okay. We can discuss in detail on
Yeah,
with
yeah, yeah.
other
Surely.
meeting. Yeah.
Okay, no problem. Thank you very much.
Hello, Mr. Saklib.
Yes, yes.
Can you hear me?
Yes, I can.
Okay, thank you very much for this nice talk. I have kind of like 2 questions that I want to get some clarity about.
Yes, sure.
The first one is how did you or how were you able to establish this data set that you have that you use in your work? I think there is a table. Can you go back to the table?
Yes.
So how did you get these values of this table from A1 to A8?
Oh, the A1 has some criteria. All the alternatives have the same criteria. Now, A1 means, let me check. A1. Yes, A1 means rice. So for the rice production, what is the importance of these criteria? Like, if we have to harvest rice, so what is its demand? What will be the expected sale price, and so on? This salmon. So this was a very important question, that what will be the importance of these 7 criteria. So to assign a fuzzy values to these criteria, it which you said this. So it means that 0.080 is the demand of the rice criteria 1, and likewise for the harvesting cost and so on. These values are assigned using the fuzzification method that I have. Uh, can you see my slide?
Yes, but I
Yes,
think
sir. So yes, so here are the falsification techniques. I have the links. So in these papers, the methods has been described how we can assign these fuzzy values to those criteria. So a variety of falsification techniques we have. How we
okay.
can assign this one, yes. So it
So
includes many, basically, let me tell you something. Basically, this falsification means we have to assign values. So when we have to assign values, we have to consider all the possibility. You can say the universal sets. So we define a mapping, a new mapping, which includes all the possibilities for that specific criteria, means demand. So what are the meanings of demand? Low demand, high demand, demand. So we have to define a mapping from 0 to 1, which means that low demand means doesn't means that 0.1. It may be in your opinion, low means 0.5. In my opinion, low means 0.2. So this was very difficult for the decision makers, how unique values can be assigned to these linguistic terms. So for each decision maker, for example, if you are a decision maker, so you can create your decision set, your fuzzification method, and after that you can assign these fuzzy values to each linguistic variable.
Okay, so if I understand, it's kind of like you have an explicit formula for doing this assignment, right?
Yes.
Oh, okay, okay.
and
Thank you.
and this helps each decision maker. This helps you, this helps me, this helps everyone to create his own decision making values, so
Yeah,
for his own
I get it.
expertise. Yes.
Thank you. And the second question is about your second approach, where you say you make use of some techniques in machine learning, for example. It seems like you say that you use random forest in particular.
Yes.
Were you able to use other versions that you discuss here, like the logistic and the SPMs and so on? And is there any comparison between the results that you have for all of these techniques? Or is kind of
So
like you try one, and since it is incompatible with your
yeah,
result in
yeah,
mathematical science, then it is better?
very nice question. Yeah, I agree with you. I have just simplified my problem only with the help of machine learning, because it was due to the you can say the graphical structure. It was relatively the same as per the problem. Uh, I will try to apply some other techniques, machine learning techniques, and will try to collect the results. Thank you for this wonderful suggestion.
Okay, thank you very much. Bye-bye.
Yes, no more question.
Okay, I think this time's up. Okay, thank you for my presentation, Sakrit. And we go to next presenter, not sure, Mr. Dolat, right? Yeah,
Yes.
you're ready, you can start.
Can you see my screen?
Yeah, I see your screen, but not full screen. Okay.
Okay, now it's full screen. Okay, thank you. Today, topic of the presentation is multifractional comparative entropy generation analysis of magnetohydrodynamic flow of Kaysen nanofluid with slipping and rampart heating. Layout of first of all, I will discuss the abstract of the
Sorry,
today
Dolat.
presentation.
Your internet is not stable.
Okay, now it's okay.
Your voice is not clear.
Now it's okay.
Yeah, now it's okay.
Okay, thank you. This is actually the layout of the presentation. First of all, I will discuss the abstract of the present talk, and after that, I will introduction of the background of the research and scope and objective of the research. Then I will discuss the results, that is the mathematical modeling and solution and results. And the last, I have some conclusion from the present study. This is main abstract of present problem, that fractional calculus is gain attention in applied and pure math science in the last 2 decades due to its valuable contribution. Due to this contribution, this article focus the comparative study of entropy generation in magnetohydrodynamic flow of Kaysen nanofluid with slipping and rampart heating effect on the plate. The governing equation is first of all get from by using the partial differential equation, and after that we use three different fractional derivative, that is constant, proportional, Caputo hybrid derivative, Atangana-Bellino derivative, and Caputo-Fabrizio derivative to generalize our governing equation. After that, the Laplace transform approach is used to find the solution of the generalized governing equation, and sometimes we cannot find the inverse Laplace transform, so we use the Riccian algorithm for this purpose. And the entropy production is explored and compared for Kessel nanofluid with three fractional model and 4 different nanoparticles. We actually consider 3 different nano fractional derivative, which we model or model generalize, and we take sodium alginated base fluid, and we take 4 different type of nanoparticle. And after that, we have Bijan number is also compared for the propose 3 fractional derivative, and we conclude from the graphical illustration, graphical representation, that CPC mean that constant proportional Caputo hybrid derivative model is more realistic than Atangana-Bellino and Caputo-Fabrizio fractional models in the case of ramp wall temperature, while in the case of isothermal wall temperature, the result are vice versa. From very basic definition, as we take the fluid, so we must know about the fluid. Fluid actually is a material that have no fixed shape and is deformed under any applied stress, and it also gain the shape of the container. There are main 2 types of fluid, that one is Newtonian and the other one is non-Newtonian fluid. Those fluid which obey the Newton law of viscosity are called Newtonian fluid, and which do not obey the law, the Newton law of viscosity are called non-Newtonian fluid. In non-Newtonian fluid, we have many types of fluid. One of them is Caisson fluid. Actually, Caisson fluid is a type of non-Newtonian fluid which exhibits both viscous and elastic behavior. It's named after John Caisson, who first introduced this concept in 1959. And Caisson fluid can be defined as a shear thinning liquid, which is assumed to have n infinite viscosity at 0 rate of shear. A yaw stress below which no flow occur, and a 0 viscosity at n infinite rate of shear. Caisson fluid have application in various industries such as food processing, oil drilling, and pharmaceutical and biomedical. Caisson fluid have a yaw stress, which mean they behave like solid until a certain stress is exceeded, and they exhibit shear thinning behavior, which mean that their viscosity decreases with increasing shear rate. And the viscosity of Caisson fluid is not constant, but it depends on the applied shear rate. And Caisson fluid have a higher apparent viscosity at low shear rate compared to Newtonian fluid. These are some application of Caisson fluid. The Caisson fluid can be applied. Caisson fluid have important application in food industry, where their yield stress and shear thinning behavior make them useful for products such as sauces, dressing, and ice cream. And in the oil industry, Caisson fluid are used to model the flow of draining mud and other fluid in pipes. They are also used in pharmaceutical formulation, where their non-Newtonian behavior can affect drug release rates and viscosity. Also, we consider the heat transfer inverse study. So we must know there are main 3 types of heat transfer: the convection, conduction, and radiation, which is very familiar. We take the magnetohydrodynamic study. Actually, this study, MHD mean that the study of magnetic property and behavior of electrically conducting fluid. And the effect was initiated by Harris Elfman. And for this achievement, he received a Nobel Prize in 1970 in physics. This is the main application of MHD that MHD can apply in magnetic therapy, MRI, and magnetic hyperthermia, and so on. As we consider the nanofluid, we must know about the nanofluid. Initially, Maxwell tried a microparticle, but he put the microparticle in a base fluid, but microfluid failed because the sedimentation and collision and blockage of narrow channels. After that, in 1995, Choi at Argonne National Laboratory, USA, used the nanomaterial size particle in a base fluid, and the resulting fluids are known as nanofluids. This is the simple preparation of nano fluid that we put the nano-sized particle in a base fluid, and we have some mechanical process. After that, we get the nanofluids. Also, we consider the entropy generation. The concept of entropy was first introduced by Rudolf Clausius in 1850 during his study on the thermodynamics of heat engine. He defined entropy as a state function that describes the amount of energy in a system that is unavailable for doing useful work. In 18th century, Ludwig Boltzmann developed a statistical interpretation of entropy, proposing that entropy could be understood as the logarithm of the number of microstate in a system. This approach provided a more intuitive way to understand entropy in terms of probabilities and statistical mechanics. And the concept of entropy has since been applied in many fields of science, mathematics, and so on. In today's concept, entropy continues to play a significant role in many area of science and technology. It has application fields such as computer science, artificial intelligence, renewable energy, where it is used to optimize efficiency and reduce waste. Entropy actually expressed as the unit of energy per unit in terms of fluid mechanics. Unit temperature, so the joule per Kelvin or calories per degree Celsius. The change in entropy of a system is related to the heat transfer that occurs during the physical or chemical process. And it is denoted that delta means the change of entropy Q by T, where Q is the heat transfer and T is the absolute temperature. Now, entropy generation. In thermodynamic system, entropy generation refers to the amount of entropy created during irreversible processes such as heat flow, fluid flow, diffusion, Joule heating, friction, and viscosity. According to the second law of thermodynamics, the total entropy of a system remains unchanged during a reversible process, and complex system undergoing irreversible change in flow and heat transfer process cannot be return to their initial state, resulting in energy loss and an increase in entropy. Bijan showed that entropy production is a useful tool to study the effect of irreversibility in a system, and understanding the cause of entropy production can help minimize energy losses in a system. This is the main difference between the entropy and entropy generation. Entropy actual measure of degree of disorder in a system, while the entropy generation measure of increases in entropy due to irreversible or inefficient process. And entropy represents amount of thermal energy that cannot be converted into useful work, while on the other hand, the entropy generation represents amount of energy lost or dissipated during a process. Entropy describes the state of a system, while the entropy generation describes the process by which the system changes from one state to another. Entropy is a property of the system by itself, while the entropy generation property of the process that drives the system. The entropy change of reversible process is zero, while the entropy generation change of any reversible process is a positive. And this is the main application of entropy generation. That entropy generation can be useful application in thermal engineering, engineering production, heating process, lubrication phenomena, cooling of devices, and extraction process. Also, we use a fractional calculus, so we must know some background about the fractional calculus. In 1695, when L-Hospital wrote a letter to Leibniz wrote to a letter to L-Hospital that what will happen if the order of derivative is 1/2. So he replied that now it's not possible, but it will change the whole science. And recently, there are many fractional calculus. Different definition of fractional calculus are become after the first one is the Riemann-Revilliu, which is the combination or the combined collaboration of Riemann and Revilliu in 1867. After that, Caputo, Michael Caputo introduced the Caputo fractional derivative in 1967. And after that, in 2006, the constant proportional Caputo fractional derivative was introduced by Hilbers, and the collaboration of Caputo and Fabrizio introduced the Caputo-Fabrizio fractional derivative in 2014. And in 2016, Atangana and Bellino collaborated, and he defined the Atangana-Bellino fractional derivative. And all are very famous, and all are their own application and their own uses. Why we use fractional calculus? Now, question is, so actually, fractional calculus is able to show the memory effect of physical phenomena. When we model the physical phenomena through fractional derivative, so it gives us more realistic results as compared to the classical model, which we model by classical derivative. And the results obtained from the fractional model is reliable and more realistic. More exactly, by adjusting the fractional parameter, the obtained result can be compared with experimental data for an excellent argument. Sometimes we find the experimental data and we have a mathematical model, but it cannot overlap exactly on each other by taking all the physical parameter as we take in experimental data. So we have another possibility that we can take the fractional derivative. So by taking the different value of fractional derivative, we can adjust a good, excellent argument with the experimental data. This is the research methodology which I adopt for this problem. First of all, I propose the problem which have mathematical formulation in the form of partial differential equation, which is main on the governing equation in which conclude the momentum equation and an energy equation with some physical initial and boundary condition that we have slipping and rainfall temperature on the boundary condition. And after that, we apply the non-dimensionalization and dimensional analysis to make our system dimensionless. And after that, we apply the fractional operator, which I mentioned in the abstract. We apply 3 different fractional operator to make our system generalized. And after that, we apply the Laplace transform method to solve our equation. But sometimes we cannot find the inverse Laplace transform of the complex equation. So for this purpose, we use the Khan algorithm method to find the numerical inverse Laplace transform. And finally, we get the solution in the form of temperature and velocity equation. And finally, we apply we use mathematical software that MathCAD 15, and we find the graphical representation of different embedded parameter on the velocity and temperature profile. This is the more relevant article, which is related to this study. This is the physical geometry of the model. The flow is along x-axis, while the magnetic field B naught is perpendicular to the fluid, and this one is the momentum boundary layer, thermal boundary layer. The fluid is case and nanofluid, and the medium in which the fluid is through is a porous medium. This equation 1 represents the momentum equation of the present problem, which I discussed in the previous geometry. In which we see that NF represents the nanofluid, that this model is for the nanofluid, and we take the Cation fluid as well, and we take this porous medium and magnetic field. And the second one is the energy equation, and the third one is the initial boundary condition. And we can see from these boundary conditions that we take the slipping condition on the plate, and while the ramp wall temperature is also taken on the plate. This is the properties of nanofluid. This is the dynamic viscosity and density and so on, which is used in the previous equation 1, 2. And this is the physical properties of considered base fluid and nanoparticle. As I mentioned in the abstract, that we consider sodium alginate as base fluid, which is one type of the Cation fluid, and we take 4 different nanoparticle: aluminum oxide, copper, titanium oxide, and silver in a base fluid. But this model is a nanofluid model, so we take every nanoparticle separately, not by all at one time. For non-dimensionalization, we use this dimensionless variable, and after that, we get the dimensionless system of equation, which is in equation 4 represent the momentum equation, 5 the energy equation, and 6 represent the boundary condition. And during the non-dimensionalization, we get some non-dimensional parameter, that is porosity parameter, Prandtl number, magnetic field, and Grashof number. And this is some constant during the dimensionalization process. We get some constant here, G1, G2, and so on. Okay, and now we find the solution. So as I mentioned in the abstract, we use 3 different fractional derivatives. So first of all, I take the constant proportional Caputo fractional derivative, and I convert the momentum and energy equation by taking the Caputo CP-CF fractional derivative. For the momentum equation, we get 7, and for the energy equation, we get 8, where CPC represent the constant proportional Caputo fractional derivative definition in equation number 9. After that, we apply the Laplace transform to the equation 7 and 8, and we get 10, 11, and transform boundary condition in 12. By taking some calculation, we get the solution 13.A, 13.B. But this one is easy, but you can see that 13.B, which is very complicated and complex, so we cannot find the inverse Laplace transform easily. So for this purpose, I used the Zekian algorithm, which is a numerical inverse Laplace transform through software. Okay, now I use the Atangana-Bellino fractional derivative to generalize our model by taking the Atangana-Bellino fractional derivative in equation number 14 for momentum, and equation 15 for energy equation, and where AB represent the Atanga Merino fractional derivative, which is defined in equation number 16. This is Metter-Leffler function, and N alpha is used for the normalization of the function. After applying the Laplace transform and some calculation, we get the final solution in the form of this one. So here we also get some complex result. So we cannot find the Laplace inverse transform. So for this purpose, we also take the Zicchian algorithm. Now I use the Caputo-Fabrizio fractional derivative to generalize our model of momentum and energy equation, and where the Caputo-Fabrizio fractional derivative is defined in equation number 23. After some calculation, we get the final solution in equation number 26 and 27. And to obtain the inverse solution, we use this Zicchian algorithm, which is the numerical inversion of Laplace transform through a software. This is the entropy generation equation. In our situation, the entropy generation forward problem is equal to this one. The first term is entropy due to the heat transfer, due to magnetic field, and due to the buoyancy forces. And where this represents the dimensionless temperature difference and Brickman number. And for Bijan number, we can take the entropy due to the heat transfer divided by the total entropy generation in equation number 29. So these results can be found through software. Now the result and discussion. First, this figure represents the case and fluid parameter effect on the velocity profile, entropy generation, and Bijan number. So we can see that near to the plate, the case and fluid velocity is increased by increasing the case and fluid parameter. This is due to the heat transfer, because we take the slipping condition on the plate, and also we take the rainfall temperature on the plate. So near to the plate, the effect are high, so the density of the case and fluid is lower, and which result the increase in velocity profile. But away from the plate, the effect of rainfall temperature and the slipping condition become lower, and then the density is higher of the case of fluid, and that's why the results are inverse. And similarly, the entropy generation and Bijan number. This is the effect of slipping condition on velocity profile, entropy generation, and Bijan number. That this red mean there's no slipping condition, but when we increase the slipping condition for both ramped and isothermal temperature, the velocity and entropy is increased, while the Bijan number is decreased. The magnetic field actually, when we increase the magnetic field, it produce some Lorentz forces, and which retard the velocity profile. As a result, and which increase the entropy generation, and Bijan number is decreasing. Grashof number actually, when we increase the Grashof number, it enhances the buoyancy forces, and which enhance the velocity of the fluid. As a result, the entropy of the fluid is also increased, and the Bijan number is decreasing. This is the 4 different type of nanoparticle which we take in a base fluid sodium alginate. So we can see that aluminum oxide have lower velocity profile as compared to titanium oxide. Similar result is represented in here for entropy generation. So we can compare this result for different nanoparticle. This is the volume fractional effect on the temperature profile, velocity profile, and entropy generation. When we increase the volume fraction of nanoparticle, the temperature of the fluid is increased, while due to, it increase the concentration in fluid, so the velocity profile become decreases. As a result, the entropy generation become decreases, and the Bijan number is increases. This is the three fractional comparison graph of the three fractional derivative which we take. That one is Caputo-Fabrizio, the second one Tangana-Bellino, and the third one is a CPC. So we see that for different result for the RAM temperature and isothermal temperature in all the cases. This is due to when we see for the RAM temperature, so the CPC is higher realistic result, but for the isothermal we can see that Caputo-Fabrizio has high realistic result. This is due to the exponential kernel which is used in the definition of Caputo-Fabrizio, Tangana-Bellino, and CPC fractional derivative. To validate our problem, we can compare our result with previous result. For this purpose, we can put some result some parameter which I didn't mention here, which we take equal to 0. So we get the results which are already published by Halid et al. So it's validate our result that our result is okay. The Nusselt number is actually the rate of heat transfer. So for isothermal temperature and rainfall temperature, we increase the fractional of nanoparticle. So we can see that for the isothermal, it enhances up to 5.6%, and for rainfall, it enhances up to 5.6833. Now, this is the different nanoparticle inserted in a base fluid and find the rate of heat transfer. For the aluminum oxide, it enhances up to 5.23%, and for the copper oxide, it enhances up to 5.68, while for titanium oxide, it is 4.3, and for Ag, it is 5.1. So we can see that for copper oxide, the rate of heat transfer is more as compared to the other nanoparticle. This is the numerical presentation of the fractional parameter alpha on Caputo-Fabrizio, Tangana-Bellino, and CFC for the Nusselt number. The main conclusion that CPC fractional model is more realistic than other two fractional model for ramp wall temperature, but vice versa for the isothermal wall temperature. I already mentioned this is due to the exponential kernel, which is in the definition of these fractional operator. The sliding condition can be applied for boosting the velocity and entropy generation for both ramp and isothermal wall temperature. For alpha is equal to 1, all the three fractional derivatives are reduced to classical 1, which show the accuracy of the fractional model. And the copper base Caisson nanofluid, or we say that copper base sodium alginate Caisson nanofluid, enhance the rate of heat transfer up to 5.68, which is higher than the other nanoparticle in a base flow. Thank you for your attention. Hello.
Any question or suggestion?
Yes, I have a question.
Yeah,
Yeah.
Okay, Mr. Daulat Khan, nice presentations and a new idea I get from your this model. I have only one question, that is about the selection of the nanoparticle. That what are the motivation behind to select these nanoparticle for your base fluids? Is there any property that click your mind to choose these particles and incorporate into your nano base fluid? Thank you.
Thank you for your nice question. There is no hard and fast rule to select any nanoparticle for your base fluid, but you can see, you can read the literature that for the for the proposed base fluid, which nanoparticle can be chemically or physically we can adopt. So on that basis, we can take these 4 different nanoparticles. Hello.
Any question?
Yeah, thank you. Thank you very much. I got the answer.
Okay, welcome.
Okay. Thank you for tonight talk. The last. Okay, we move to next presenter, Mr.
Thank you.
Ramzan. Are you here? Ramzan, if you're ready, you can share your screen and let's start. You not open your microphone, Ramzan.
Hello, yes, I am here. I can share my screen. Thank you.
Okay, and your noise, maybe your more volume.
Okay, okay. Hello.
Yeah.
Good afternoon, everyone. You can see my screen.
Yeah.
Today, I am going to present the topic significance of nanoparticle radius and interparticle spacing toward the radiated water-based alumina nanofluid flow over a rotating disk. The layout of the presentations are introductions, significance of the research, literature review, and the problem formulations, conclusions. At the end, I will discuss the future directions for the present problem. In introduction sections, first I will discuss some basic definitions related to fluids. What is a fluid? A material that has no fixed shape and deform under an applied stress is known as a fluid. It can be divided into Newtonian and non-Newtonian fluids. Newtonian fluids, those fluids which obey Newton's law of viscosity, but those fluids which do not obey Newton's law of viscosity is known as non-Newtonian fluids. These are some examples of the Newtonian fluids: water, mineral oils, ethyl alcohols. And these are some examples of the non-Newtonian fluids: blood, toothpaste, honey. Further, non-Newtonian fluids can be divided into 3 categories: rate-type fluids, in which the deformation rate is proportional to the stress; integral type fluids, in which the response functions can be represented as the integral polynomials; in the differential type fluids, in which the stress depends only on finite numbers of derivatives. Heat transfer. Heat transfer is the process of heat from a high temperature system to a low temperature systems. The applications of heat transfer are solar collectors, solar chambers, and lubricants. Mechanism of heat transfer. Heat can be transferred through different waves: conductions, convections, and radiations. Now, I'm going to discuss the magnetohydrodynamics, which is the most significant phenomena we have to use in our present work. Magnetohydrodynamics is the study of magnetic properties and behavior of electric conducting fluids. The effect of MHD was initiated by Hannes Alfvén. He received the Nobel Prize in Physics in 1917. The applications of magnetic field are magnetotropy, MRI, and magnetic hypothermia. And what is nanofluids? Because I am going to discuss the present model by using a nanoparticles in a base fluids. When we mix some nanoparticles in a base fluid, then after the dispersions, we obtain a nanofluids. Applications of nanofluids. Nanofluids is used in different purposes such as solar thermal applications, in automobile applications, electronic coolings, medical applications, detergency, and military applications. These are the thermophysical properties of base fluids and nanoparticles: thermal conductivity, viscosity, specific heat, and density. Significance of the research. The outcomes obtained from this research can improve the heat transfer in a variety of industrial and engineering fields. The flow problems related to fluid mechanics are useful in real-world applications such as power plants, hydraulic machines, automobiles, refrigerators, air conditioners, thermal power plants, nuclear power plants, and etc. This study is crucial in the solution of non-linear differential equations. It has applications in different areas of life such as science, finance, and engineering. The significance of the present work is that it is very useful in different fields of bioengineering and engineering, including magnetic drugs, targeting systems, magnetic hypothermia, directing of magnetic drugs, and etc. Further, the applications of Newtonian and non-Newtonian fluids model for a higher order non-linear equations are also discussed. These are some papers related to our present work. By using these papers, we are going to study the significance of nanoparticles and interparticle spacings on the ammonia-based nanofluid. In research methodology sections, how we can propose our problems. In a mathematical formulations which consist of a governing equations along with initials and boundary conditions, such as these governing equations are energy equation, velocity equations, and concentration equations in a non-dimensional form. By using a similarity variables, and these non-dimensional equations are in a partial differential equations, and by using similarity variables, these partial differential equations are converted into ordinary differential equations. These are highly nonlinear equations, ordinary differential equations, and for their simulations, Ham methods is applied for the analytical solution of the ordinary differential equations. At the end, the effects of different flow parameters on the temperature, velocity, and concentration profiles are discussed in a graphical form. Formulation of the problem. These are some flow assumptions. Two-dimensional flow, effect of magnetic field study, the section effect study, aluminum oxide nanoparticle are used in this study. The base fluid is a water. Also, the effect of thermal radiation and viscous dissipations are also studied. The geometry of the problem is rotating disk, and we also discuss the radius of nanoparticles. This is the geometry of the problems. Here, the free stream conditions are defined, and these are the surface conditions. And V naught is applied normal to the flow directions, and the fluid motion is produced due to the rotation of the disk. On the basis of the above flow assumptions, these are the governing equations related to the present work, such as equation number 1 is known as the continuity equations. Equation number 2 and 3 are the momentum equations in X and Y directions, where in which the B naught is the magnetic field. Also, equation number 5 is the temperature equations, and QR is the thermal radiations effect, and this is the section effect we are going to study. These are the boundary conditions related to the present work are defined in equation number 6. And thermophysical properties of nanofluids. The relationship between the nanofluid dynamic viscosity and base fluid viscosity is defined in equation number 7, 8, where H is the interparticle spacing, Rp is the radius of the nanoparticles, and delta is the solid volume fractions. In table 1, thermophysical characteristics of the base liquid and nanoparticles are defined. In this study, the base fluid is water. They have some thermophysical properties, and aluminum oxide is nanoparticles. When we mix up aluminum oxide nanoparticles in a water, then a nanofluid is formed. These physical properties are used for the simulation of the problems when we are going to find out the solution of the problem. In the present analysis, the similarity transformations are disposed as this by using equation number 9. This is the similarity transformation defined in equation number 9, the dimensionless form of the equation 2 to 5. All the above partial differential equations of the momentum and energy equations are transformed into a dimensionless form. Equation number 10 and 11 are the velocity equations in a dimensionless form. Momentum. And in equation number 12, the temperature equations are defined in a dimensionless forms. Similarly, the boundary conditions are also transformed in a dimensionless form that are defined in equation number 13. After these simplifications, we obtain some dimensionless parameters such as magnetic field parameter, radiation parameter, Prandtl number, accurate number, section injection parameter, and temperature ratio parameters. In equation number 14, the physical quantity of interest it defines. By using these physical quantities, we can find a skin friction coefficient along X, Y, and Y directions. Also, by using a Nusselt number, we can find out a heat transfer. By using a homotopy analysis method, the solution of the problem is obtained. Result and discussions. In figure 2a, the variation in velocity profile against a section parameter Fw is defined. Here figure 2a, we see that when h equal to 1 is small and h is higher. For small r and greater h, the velocity of the fluid increases due to the increase of section parameter. Similarly, for a small and larger nanoparticle radius Rp, where Rp is a radius of nanoparticles, the velocity of the fluid increases due to the increase of a section parameter Fw. Figure 3a and 3b discuss the effect of magnetic field on the velocity profile. In figure 3a, for interparticle spacing h, for small interparticle spacing and large interparticle spacing, magnetic field decreases. Similarly, in figure 3b, the magnetic field also decreases due to the increase of velocity profile decreases due to the increase of magnetic field, because the frictional forces between the fluid increases. Also, a Lorentz force between the fluid particle is produced, and which slow down the motion of the fluid particles. That's why the velocity of the fluid decreases when we increase a magnetic field. The effect of radius of nanoparticle and section parameter is discussed in figure 4a and 4b. Both these figures, it is noted that the velocity profile in x directions and velocity profile in y directions are increases. In figure 5, the variation in velocity profile in y direction is noted against a section parameter and magnetic field parameter. Similarly, the velocity profile decreases due to the magnetic field parameter, but the velocity profile increases due to the section parameter. In figure number 7, the variation in temperature profile against accurate number and radiation parameter are discussed. In figure 7a, where theta w is a radiation parameter, for a linear and non-linear radiation parameter, the temperature of the fluid increases due to the increase in accurate number. Similarly, the temperature of the fluid increases due to the increase in radiation parameter for a small for linear and non-linear radiations. In table 2, the variation in heat transfer against different flow parameters are discussed. For example, if we see that the Nusselt number is increases due to the increase in radiation parameter for linear and non-linear radiations. Similarly, the effect of accurate number and nanoparticle volume fractions are also discussed on the Nusselt number of the fluids, and we see that the Nusselt number of the fluid is increases by increasing these parameters. Conclusion: in case of lower or higher interparticle spacing, the velocity profile is increased for the section parameter, whereas the velocity profile is decreases for magnetic field parameter. Further, it is examined that the velocity is higher for a section parameter, whereas the velocity is lower against magnetic field parameter for the case of small or large radius of nanoparticles. For the case of small or large interparticle spacing, the increment in section parameter lead to enhance the velocity profile while diminishes against magnetic field parameter. Further, for both small and larger radius of nanoparticle case, the velocity profile is augmented due to the increase of section parameter, while opposite trend is observed against a magnetic field parameter. Similarly, in case of temperature profile, it is increases against accurate number, radiation parameter, and nanoparticle radius for both linear and non-linear radiations. This problem can be, we can extend this problem in different ways, such as we can study for different Newtonian and non-Newtonian fluid models, such as for Kazan fluid, micropolar fluids, and different geometries such as stretching sheet, exponential stretching surface, moving plates, inclined plates, rotating disc and cylinders, and moving thin needles. And we can use different base fluids and nanoparticles to study these problems. Also, we can study this problem by using different boundary conditions, such as convective and slip conditions. Also, we can find different numerical techniques and compare their results with published results. Thank you. If you have any question.
Yes, Ramzan,
Yes, yes.
can you
Hello.
hear me? Yeah.
Yes,
Is,
yes.
what is the relationship between the base fluid and the nanoparticle? Is there any relationship between them?
No, there is no relationship. Just we for the formulation of nanofluid, we can use nanoparticles in a base fluids. That's why we can use a nanoparticle in base fluid. There is no specific relationship between these nanoparticles and base fluids are.
Oh, now that is if I choose my base fluid, I can choose any nanoparticle, right?
Yes.
Okay. Okay, thank you.
Thank you.
Sorry, I have some questions.
Yes, yes.
So can you explain more how use the work, your work that use that that I want to say. How does your work improve or help or using for any the for in the nanofluid?
Yes, we can improve it.
And
For example, I understand your question. For example, if in this study, we discussed base fluid is water and nanoparticles, aluminum oxide nanoparticles. We can improve it by using a different nanoparticles. For example, if we mix 2 nanoparticles in a water, then it affects more effects on the heat transfer.
Oh, calculate the heat
Yes.
transfer, right?
Yes, yes, yes.
Between
Yes, yes.
we use the when the between flux of water and some
Nanoparticles, yes.
okay.
Yes, yes.
That
Similarly,
is
like in case of hybrid nanofluid.
Thank you so much. Any question or suggestion? Okay, if no question, thank you for nice present, Mr. Ramzan.
Thank you very much.
Okay, we move to the last presenter for today. Mr. Asoka, are you here? Okay, you ready? You can start.
Okay. Can you see my screen? Can you see my screen?
Yes, I see.
Okay. Good afternoon, everyone. My name is Ibrahim Arzuka, and the title of my last seminar is International Human Migration Network under regulation. So this is the paper that I'm going to use for this presentation. So these are the outline of my presentation, and this is the paper that I'm going to use for this presentation. So I'm going to begin this presentation by considering these 2 images, where in the first image, we have a set of immigrants trying to cross the Mediterranean Sea. And in other image is another set of immigrants trying to cross the border of a given country. So human migration can be defined as the movement of people from one place to another with the intention of settling temporarily or permanently in the given new location. So we can define an international human migration as the movement of people from one country to another country with the intention of settling temporarily or permanently in the new location. So this kind of migration has happened since the beginning of life. And some of the factors that leads to the human migration are, we have war, like the kind of war that is happening in Ukraine, like the Syrian war, and so on and so forth. And also we have other factors are the economic inflation of certain countries, such as Venezuela. So also we have climate change, like the flood that has happened in some part of the Asian country, and then droughts in the African countries. And some of the factors are, some are educational and business purposes. And finally, we have the family reunion. So these are the data for human migration. As you can see from this slide, that internationally, we have 281 million immigrants, which are staying in a country different than their own, with the female immigrants 105 million, the male immigrant 146 million, and those that are serving as workers, immigrant workers 116 million, and those immigrants that were lost along the way. So as you can see from this picture, the path, the route that the immigrants take for this purpose is very risky, which resulted to loss of life. A lot of people lost their life. So as a result, we have these statistics which indicate the deaths of immigrants along the Mediterranean Sea. As you can see, in 2016, about 5,000 people lost their life along the way. So these are the paths that the immigrant normally took. and most of the targeted place are the European countries, with few move to the Asian and the North American countries. So the international migration is considered as a global challenge. As a result, government of various nations are increasing focusing multiple challenges associated with human migration flow. So in response to these challenges, there are several regulations that have been imposed. This shows that the government wants to find an equilibrium solution to this given to the given problem. So as a result, in this paper, they assume a closed economy in which there are n countries under consideration, with the country of origin and the destination denoted by I and J respectively. And immigrants are classified into three. That is, there are those that are highly skilled immigrants, some are skilled, others are unskilled. And these categories has to do with those that are refugees and asylum seekers. So this is just a structure showing the movement of the immigrant of various classes. As you can see from this picture, we have these are the original countries and these are the destination countries. But these classes of the immigrant varies. An immigrant can decide to move from his original country to country J, but as a result of this movement, there is a cost associated with the flow of the immigrant. Similarly, that is what attracts him to move to this country. We call that utility. So another immigrant will decide not to move to J, to another country. That's why we have a couple of these structures. So as a result, these are some definition of terms that we are going to use. We are this P by I of K in the initial fixed population of class K in country I. And this, the second one, this indicates the population of class K in country I. This indicates the flow of the immigrant from country I to country J of class K. And this is the cost of flow from a given country to another country. And this is the utility, the attractiveness of a given country that the immigrant of class K expected to be achieved. So since we are talking of a population, we are going to have what we call conservation of the population. And this equation 1 indicates the conservation of the initial fixed population of class K. Similarly, the population of class K in country I can also be conserved by using this equation 2, as well as we can define the population of a given class in a given country by this last equation. So now this is the equilibrium conditions for the given problem based on the paper. While what this is saying is that when the maximum utility is greater than 0, then we are going to have a positive flow. And as a result, the gain in utility is equal to the cost of movement. So this is just the summary of this equilibrium condition. If this condition is satisfied, then this point is in equilibrium. So now we can formulate the variational inequality problem, which is going to be used to solve this kind of problem as equation 5. That is the population, that is the utility depends upon the population, and also the cost of flow depends upon the flow of the immigrant. And these are the constraints. Now, since the government focus on regulation, we can have this equation 6, which guarantee the regulation based on the government. And based on this 6, we can say that the government can impose the regulation as follows. They can specify a country I, they can restrict the movement of immigrants from country I, irrespective of the class. For specific class K, that is, they will restrict the movement. They will say, okay, now we just want skills immigrant from country I to country J, and this is the upper bound. This should not exceed 1,000 or 2,000. So this is just what this is saying. Similarly, this one, the regulation is specific country I, irrespective of the class, just country, any class, but they will say that, okay, only country, you would say that, okay, those people that are from so country, they should not exceed so amount of people. And they can also restrict the movement, all immigrant of class K from a given countries. So now the racial equality problem remain the same. Also the group condition remain the same, but the concept set is now changed as this. So this is just a simple example to demonstrate the problem where we have two countries that have immigrant and immigrant want to migrate to either 2 or 1. And this is the initial population of the immigrant that wanted to move. We have 50, but in country 2, though all of the people in country decided not to move. They said no, they are not going. They are not going now. And this is the utility attractiveness of a given country. This is attractiveness of this is the utility assumed to be perceived in country 1. And this is the utility believed to be achieved in country 2. So this is the cost of flow from country 1 to country 2. And this is also the cost of flow from country 2 to country 1. So these are the algorithm used, which is the modified projected method. That's after the initialization, the computes X bar using the variation quality problem. So problem. Also the compute the SK plus 1. Finally, they check for optimality. If it achieves stop else, we go to step 1. And this is the equivalent solution based on the problem. As you can see, that there is a positive movement from country 1 to country 2. 30 people decided to move. The algorithm assigned 30 people to country 2. Also from country 1 to other country 1, 20 has moved. But in this, there is no movement between these two flow. And this is the final population in the corresponding country, in the destination country. Now the population has increased at 20 population. Similarly, in the second country, 30. As you can see here, we can see that clearly the economic condition is satisfied. Thus, the population is conserved. If you add this 20 plus 30 is going to give you 50, which is the initial population, that we have started with. So these are the cost. This is the utility achieved in the first country, and this is the utility achieved for those that move to the second country. And this is the cost associated with the movement from country 1 to country 2, and this is also the cost associated with other country. So thank you. Is there any question? Yes.
Thank you for this wonderful presentation. I can see that your presentation involves, or your work involves data related to human.
Yes.
So based on the CT program we took,
okay.
How do you categorize your research now? Do you need permission to use this human data from your source? Or how do you see it? How do you categorize your research?
Yeah, this data actually is from UN, the United Nations. It has been agreed. It's in the portal.
I understand. Data from United Nations, or from who? You don't need any permission to use them actually. I understand. Thank you very much.
Okay, thank you for your question.
Dr. Kazuka, that's
Yes.
very nice talk. I am really interested in this kind of things. So I'm curious, like, do you intend to consider the case of immigrants from Thailand to elsewhere? or you want to consider from elsewhere to Thailand?
Yeah, we hope in the near future, we are going to consider those from those that decided to come, those immigrants here in Thailand, whatever is their utility that they achieve.
Oh, okay. Because
Okay.
you can see many of immigrants here.
Yeah,
visiting
there are
Thailand.
a lot of immigrants.
And also some Thailand are also going elsewhere. So this
So-
will be a great project for the government for the government to take up. That's
Okay,
good.
okay. I will
Yeah.
also look into that.
Okay, thank you.
Thank you very much.
Okay, if no question, thank you, Mr. Asuka. Okay, today we finished for the talk. Everyone, please turn on your camera. Stop share, please, Asuka. We